Today you're going to learn about the Big Bang, our expanding universe and humanity's changing view of the cosmos. So first of all, we need to talk about what cosmology means. Cosmology is the study of the universe. It's the study of the universe's structure, its origin or where it came from, where it started, its evolution, how it has changed and how it is changing, and also its future. If we take a look at cosmology throughout history, it's changed quite a bit. It started out with a Earth-centered view, the idea that the Earth was at the center of everything, at the center of our solar system, and at the center of the universe. Claudius Ptolemy was the first person to really set forth this theory, that the Earth was at the center, and this theory lasted for about 1,500 years after Ptolemy. It wasn't until the 1500s that astronomers and scientists and society started to believe in the idea of the sun being at the center of our solar system. Nicholas Copernicus was one of the first to really propose this and have some research behind his theory. And this just said that the sun was at the center of the solar system, then the Earth and the other planets rotated around it. And this also led to the idea then that the Earth was not the center of the universe, but that the sun is just one of many stars in our galaxy, and then now we've come to realize that our galaxy is just one of many in the universe. And then in the early 1900s, a man named Albert Einstein, a theoretical physicist, proposed this idea of the formation of the universe and how the universe first formed. And so he's the one that came up with the Big Bang theory. So what is the Big Bang theory?
State that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a...
No, I don't mean the television show, even though I think it's a great show. Right now, I'd like you to get out your science notebooks, and I want you to write down these 4 main points about the theory. The first one is that the universe started as a single point, that this single point was extremely dense, that it became unstable and exploded outward, and today the universe continues this expansion. So please take a moment to write those 4 points down about the Big Bang theory. Now we're going to take a look at where's the evidence to the Big Bang theory. Now, the Big Bang is a theory about how the universe formed, and this is the leading and most widely accepted theory at the moment that most astronomers and scientists are in support of. So we're going to take a look at the evidence, because this is not just an idea that someone thought up of and everyone just decided to go along with. There is quite a bit of evidence that supports this theory. So first, our first piece of evidence that I want you to write in your notebooks is that galaxies are moving apart from each other. This is a piece of evidence. This is something that we know is happening. We see that only a few nearby galaxies are moving towards our galaxy and they appear bluish. However, all other galaxies that we observed are moving away from us, and we know this because they are shifted towards the red end of the spectrum. So if you take a look at this here, you see that in the center here, this is the spectra of a galaxy that would be at rest. And then if we look at the top here, see how all of the spectral lines are shifted towards the left, towards the blue end of the spectrum? That means that that object would be moving toward us. If we look at the one at the bottom here, we see that those spectral lines are shifted to the right or towards the red, and that means that the object is moving away from us. So this is how we know that celestial objects, if they're moving toward or away from us, is we look at their spectral lines, which is just it shows us what elements are present in them, and if those lines are shifted towards the blue end of the spectrum, they're moving towards us. If they're shifted towards the red end, it means that the object is moving away from us. And so here's a quick little diagram that can kind of help you remember this. So I want you to put this underneath this first piece of evidence here, a drawing like this that kind of shows you that if it's moving, something like the sun is moving away from the observer, it has red shift, and it's moving toward the observer, it has blue shift. I know that this idea of red shift and blue shift can be a little bit confusing, and so don't worry, we will be talking about it a little more in class, and I have a few other things to show you to hopefully help you understand it a little bit better. But redshift is evidence of an expanding universe. But how then does this support the Big Bang theory? Okay, so the universe is expanding. Why does that mean that it had to start with the Big Bang? Well, if the universe is expanding, that means that it must have been smaller in the past. And at some point, the entire universe would have been a single point and started expanding and continues that expansion still today. So our second piece of evidence that I want you to write down is that we have leftover heat from the Big Bang. It makes sense that if there was an explosion on this large of a scale, that we would still see a little bit of the heat today. And we do see it. We actually have mapped the universe and the heat in the universe, and we see kind of a small whisper of that heat still throughout the universe, like you see in this picture right here. And this is called microwave background radiation. In the mid-1960s, Arno Penzias and Robert Wilson detected this leftover cool-down radiation from early in the universe's history. They carefully scanned the sky with a device called the Holmdel-Horn antenna. And this discovery was very important evidence in support of the Big Bang theory. And it actually won them the Nobel Prize. And this is another thing we'll be exploring a little more in class in more detail. And since then, we have the COBE, or the Cosmic Background Explorer, and this was launched in 1989 by NASA to measure the diffuse infrared and microwave radiation from the early universe. And guess what? And this is where we see that map that you saw in that first slide, of the map of the actual radiation, leftover heat from the Big Bang. Our third piece of evidence is that the universe is mostly hydrogen and helium. Well, we know that our sun is mostly hydrogen and helium. If you've been in my astronomy class, you know that that's what most stars are made out of. But we've actually discovered that about 74.5% of the universe is hydrogen and 24% is helium. And those are of the known elements. We'll talk about dark matter and dark energy in a minute. But of the known elements, it's mostly hydrogen and helium. This was discovered in 1925 by Celia Payne. And by the way, she was only 25 when she discovered. So you might wonder, well, how does this fact support the Big Bang theory? Well, let's step back a little bit and look at what would have happened during those first moments. So during the first moments of the Big Bang, it was like proton, neutron, electron soup. There were no elements that were formed. It was just these smaller particles kind of floating around together. About 3 minutes after the actual explosion or the actual bang, there was a small window of opportunity where the pressure and temperature dropped just slightly for elements to form. And during this window, protons and neutrons were colliding just enough to stick together, but not so hard and with such high heat that they wouldn't stick together. And this formed hydrogen and helium atoms. After that, the temperature and pressure dropped more, and so these collisions were too rare. So it was only during that small window of opportunity where hydrogen and helium were formed. So what is the result? A lot of hydrogen and a little bit of helium. And that's what our universe is made up of. All of those heavier elements, where do they come from? Fusion inside of stars today. So any heavier elements have been made inside of stars since the Big Bang. So our fourth piece of evidence. Our fourth piece of evidence is that distant galaxies are less evolved. Well, what does this mean? Because aren't all galaxies the same age? Well, they are, but the ones that we're looking at that are farther away, we're actually seeing farther back in time. I know. So we're talking about time travel now. Well, not really. What we're saying is that it takes light a long time to get to us. So for example, if we take a look at the constellation Orion here, there are 3 stars in his belt, Alnitak, Alnilam, and Mintaka. And those 3 stars are about 1,000 light years away. So that means that here on Earth, when we see those 3 stars, we're actually seeing light that left those stars about 1,000 years ago. We're not seeing them as they look right now at this moment in time. We're seeing them as they looked 1,000 years ago. So the farther away we look, so the more advanced our telescopes get, the farther and farther away we're able to look, we're actually looking farther and farther back in time, because the farther away the object is, the longer it takes the light to get to us. So when we see galaxies like the ones you see in this picture here, those are billions and billions of light years away. And so we're seeing them as they were closer to their formation, and so we see them less evolved. This tells us that the older a galaxy gets, the more it evolves. So at the beginning of the Big Bang, when the galaxies were first forming, they were less evolved, and over time they start to evolve and have more of a uniform shape. Our fifth piece of evidence. Well, this is kind of a new, interesting topic here, and this is that 90% of matter in the universe is actually dark matter or dark energy. Einstein's Big Bang theory relied on this concept of there being some sort of mysterious energy of space, and he didn't know what to call it, but he knew that in order to explain his theory, this energy had to be there. It's an integral part of the theory, and it's the only way to explain the fact that the expansion of the universe is speeding up. So not only are the galaxies moving apart from each other, that expansion is actually speeding up. And the only way to explain that is if there's this sort of mysterious matter out there that. So here's a nice little visual that shows us the percentages of stuff that we have in the universe. And you can see that normal matter, the stuff that we can see and touch and think about in our everyday lives, atoms, compounds, elements, everything in the periodic table, this only makes up 4% of the universe. The other 96% is this mysterious dark energy and dark matter. And we'll be talking about this a little more in class so you can get a little more familiar with it, but we're really only going to scratch the surface. And so what's important for you to know is that scientists think it exists, and they're coming closer to predicting that it exists. So let's review. What is the Big Bang Theory? And what are the 5 main pieces of evidence that support this theory? So remember, the universe started as a single point. That point was extremely dense. It became unstable and exploded outward, and today the universe continues to expand. And then our evidence for the Big Bang Theory are that galaxies are moving apart from each other, and we know this because of the redshift that we see. There's leftover heat, and we know this from the microwave background radiation. The universe is mostly hydrogen and helium. Distant galaxies are less evolved, and the further away we look, the further back in time we're looking. And more than 90% of matter in the universe is dark matter or dark energy. So now it's time for you to take a few minutes to think about, well, how do you feel about this theory? Think about the evidence that's been presented, and we'll talk a little more about each piece of evidence in class and research it a little more in depth.